Okay, we're in section 25 of the notes now, and let's just review. So I realize there's a lot of repetition, at least in the beginning of these things, but each section's different. They're related. Certainly you need to know the past sections before you can go forward. But again, my name is Ron Bannon. This is the draft version of my adaptation of Webster Wells' Advanced Algebra course that's circa 1904. All right, this is the materials for exercise 25. So what do you get? You get contents, you'll get examples, and you get exercises. This material, at least the PDFs are being made available to the Prison Mathematic Project participants only. It will be published, but at a later date, all right? So if you need to reach out to me for whatever reason, again, my name is Ron Bannon. My email address is Bannon, that's B as in boy, the @ symbol, NNON.US. I'm in the United States. All right, so what I'm going to be doing is basically what I do for each section, kind of scroll through it, and saying that what you need to do. You need to read this section on the least common multiple. Not difficult. Certainly most students have done this before. Certainly, as you're reading through Wells's textbook, you might be a little bit confused by the way he treats things, but he's very precise. I'll say that. All right? The goal here is to get the LCM. Now, certainly what I do, what Wells does, may look different, but the intent is the same, to get the least common multiple. All right, that's really important. I'm looking for an LCM, and that's really important. That's what we're looking for. So, for example, I'd hate to go back to what you might have done in grade school. If you were given numbers, you might write all the multiples down. People often confuse the word multiple with the word factor. They're different. For example, the multiples of 4 are 4, 8, 12, 16. What am I doing? I'm just adding 4 in each time, and this goes on forever. Now, if I had the multiples of 9, that would be 9, 18, 27, 36. I think you get the idea, right? Now, someone said, what's the LCM between 4 and 9? If I were looking at those two lists, I don't see anything they have in common, so I have to continue. Now, certainly going to continue in the 4. You get 24, 28, right? 32, 36. 36 the LCM. Least common multiple. I'd hate to see someone do it that way. All right, but that's probably the way they taught you, at least in grade school, to get common multiples. Right? There's other ways of doing it, and I want to point that out to you. Probably when time you get to middle school, if the teacher said, the LCM, I don't think they write the multiples down. They probably take the number 4, and they write down 2 factors for that. Now, someone says, why 2 and 2? 2's a prime, and that's why they're doing it. And if I put 9 down, they put 3 times 3, right? 3 is prime. What are the prime numbers? 2, 3, 5, yada, 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 all right? They're the numbers, I should say integers, greater than 1, such that the integer is only divisible by itself and 1. All right, so 2 fits description, 3 fits description, 5 fits description, 6 doesn't, 7 does. 7 does, whoa, what am I saying? 7, 9 doesn't, so forth and so on. What's the LCM? It must contain those factors. Now, so what do you mean by that? It must have a 2 in it. It must have a 3 in it. Now, here's the problem a lot of students have trouble with. The maximum number of times those factors occur in any one factorization. Well, a 2 occurs twice, and a 3 occurs twice. That's the most. What do you get now? 4 times 9, which is 36. I really think the best way to LCM is just simply to look at it and say what the LCM is. So let me look at these 3 separate terms. Term 1, term 2, term 3. Now again, if you know the LCM, write it down. You are done. What I want to do is just simply write down the factors. Now someone says, you already done that for me? Yeah, we have. Let's go through that. So, for example, on 36, if I were to do that tree diagram on 36, let me put out what I mean by that. That would be 2, 18, 2, 9, 3, 3. All right, sorry about that. So that's why I put down there's 2 2s, 3 3s for that. Now, certainly there's 3 factors of A and 1 factor of X. You notice I'm putting dots in there for you. Let me get my eraser out, and let me do the next number. And certainly these might be difficult. 60, And I like to start low. 2, 30. Whoops, let me sharpen my pencil. 30 breaks into 2 and 15, and 15 breaks into 3 and 5. So what'd you get? 2 2s, 1 3, and 1 5. All right, let me get my eraser out. Actually, let me erase these little check marks too. Let me just look at the A. It's A squared Y squared. That's pretty easy. Let me do 84. Oops, sorry about that. And again, I like to start easy. It's even number, 2, 42. 2, 21. 3, 7. So what am I going to say? For 84, gee, I wonder why I wrote down 2 2s. You could write down 2 squared for that. It doesn't much matter. And you get a 3 and a 7. Not so bad. All right? You get a C and an X cubed. So the way I would write this down, I write LCM must contain those factors. I definitely see a 2. I definitely see a 3. I definitely see a 5. I definitely see a 7. Certainly I like to go in alphabetical order. I'm seeing A. I'm seeing a C. I'm seeing an X. And I'm seeing a Y. Okay. What's the maximum, in any given term, what's the maximum number of 2s that I see? 2. So I'll put this down. How about the 3? 2. That's the maximum number of times it occurs in any one factorization. How about the 5? Just once. How about the 7? Just once. How about the A? I'm scanning over it. Looks like A cubed to me. How about the C? Once. How about the X? 3. This is the maximum number of times that factor occurs in any one factorization. And then 2. And again, I know this seems difficult, but I want to go through it with you. So 2 squared is 4. 3 squared is 9. 4 times 9 is 36. Let me write that down for you. 5 times 7 is 35. I'll do that later. A cubed, C, X cubed, Y squared. Let me go through the multiplication. I'm going to do this on the side for you. 36 times 35. 5 times 6 is 30. 5 times 3 is 15. 15 plus 3 is 18. Let's see. 3 times 6 is 18. Okay. 3 times 3 is 9, and then I get 10. What do you get? 0. 8 and 8 is 16. Carry the 1. This is 2. 1, 2, 6, 0. That's a pretty nasty looking number, by the way. A cubed, C, X cubed, Y squared. I'll put a circle on this. I'm always saying don't look at the answer key. Sometimes my eyes do gravitate towards that. But I want to make sure I got the right LCM. 1260, A cubed, C, X cubed, Y. Worked out beautifully. Let's go to the next one. Next one, what I got to do is I got to find the factors. So what I would recommend is look at each of these guys. Let me find out what I mean by that. I need to look at that, factor it. I need to look at that and factor it, and that and factor it. I'm going to say they're pretty easy to factor, and you certainly have been factoring these for some time. So the first one, and that's X and X. I'd say 3 and 2, plus 3, minus 2. Let's do the next one, X and X. And looking at that, I'm going to say it looks like minus 2, minus 2. The last one, a little more complicated. That's X, and then you get X squared, minus 9. And then what you see over there, you get X, X plus 3, X minus 3. So again, I'm going to say the LCM must contain those factors. What factors do I see? X minus 2. I see an X. I see an X plus 3. And then I see an X minus 3. Okay. What's the maximum times the factor X minus 2 occurs in any one of those terms? It's twice. What's the maximum times the factor X occurs in any one of those terms? Once. What's the maximum number of times the factor X plus 3 occurs in any one of those terms? And I got 3 terms over here. Let me just remind you. Once. X minus 3, once. Let me clean it up a little bit. I'll put the X up front, and then I'll put down, I don't know, let's start with the X minus 2 squared. Then you get X plus 3. x minus 3. I'll put a box in that. And certainly when I'm putting a box in something, I'm committing to it. But I want to see if I got the right answer. And I'm looking at it, and we have the right answer. The order in which the factors are listed is incidental, by the way, multiplication or commutative. But it is nice to put single factors up next, followed by the binomials. Okay? Let's go to the next one. Relatively simple questions. Oh, there is no next one. That's really good news. Because what does it mean? It means that, Wells is of the belief that he's covered enough material for you to try this stuff on your own. Now, I do put work down for these, for the exercises, but I would say when you're doing the exercises, what you need to do is do problem number 1 on a piece of paper, look at the key to make sure you can agree with what's been stated. If for whatever reason you're not agreeing with what I stated, you know what? Maybe I made a mistake. It's possible, all right? But I go through all the questions. I put down some work. I'm going to say enough work for most students to be able to follow what's going on over here. Some of these are more difficult than the others. I'll tell you why. It's the factor that makes it difficult. All right, let me go over to SAGE business. And I know for some students saying, do I need to do SAGE? No. SAGE is something that comes later in your life. This is like, I'm not going to say basic algebra. It's really an advanced course in algebra. As we move forward, it can get much more difficult. But and don't be discouraged by that. The reason I'm saying it's getting more difficult, it's like any journey. In the beginning, you start out kind of, getting ready for it. And all of a sudden, the hills get steeper. And that's what's going to happen. Some of these hills that you're going to be climbing get really, really steep. But in the future, you're going to need a tool to help you through your mathematics career. The tool that we're talking about is what's known as a computer algebra system. That's abbreviated CAS. A good CAS would be SAGE. When I say it's good, because it's it's free and it's widely available, and it's used all over the world. It is like in any big university, SAGE will be at their disposal. I would imagine any company that does math is also has a copy of SAGE around, all right, and has a copy of it, and they're using it, all right. It's a really powerful product, all right. I would recommend, either you download the application or you use the web-based application, and then just type the code in and see what it's doing. It's factoring, and then there's another command, LCM, and you might be confused by what's written over here. It's important that you read what you're typing. So I'm always saying you could do a copy-paste, but you really should read what you're typing, or at least read what you're copy-pasting, all right? Read it, all right? Now, notice this is an embedded LCM, and the reason for that is, the standard LCM function takes 2 arguments. So if you have 3 arguments, you got to take the first 2 arguments, get the LCM of that, and then combine it with the 3rd argument. You could imagine this gets pretty nasty. The other thing I want to point out to you is this thing at the end which says factor. And why is that? I want my LCM to be in factored form, and we've always put them in factored form. Okay, I know it's the beginning I said, if you need to reach out to me, please do so. Let me just remind you, my name is Ron Bannon, and my email address is Bannon. That's B as in boy, ANNON.US. Yes, I'm in the United States. Thank you for paying attention. Good luck.